Now, operation of PN junction diode in forward bias. How the PN junction in forward bias? When positive terminal or anode of the battery is connected to the P-type or anode of the PN junction and negative terminal of the battery is connected to the N-type or cathode of the PN junction, then this setup is called forward bias. This is a battery and this is a diode. A PN junction is formed as following figure. You can observe this figure. When the PN junction is in forward bias, as long as the applied voltage is less than the potential barrier voltage. This is the depletion layer or potential barrier, which is having a voltage V0 up to the battery potential applied to the PN junction is less than the V0, that is potential barrier voltage, then there is no any conductivity. When the applied voltage becomes more than the barrier potential, this barrier potential voltage is less than this battery. When the applied voltage becomes greater than this barrier potential, in that scenario, what happens is the negative terminal of the battery pushes these free electrons against the barrier potential from N-type to P-type region. In the similar way, the positive terminal pushes the holes of P-type region to N-type region. Thus, holes get repelled by this positive terminal and electrons gets repelled by this negative terminal and crosses the junction. These holes crosses like this and these electrons crosses like this. Thus, applied voltage overcomes the potential barrier voltage. This battery voltage applied is greater than the potential barrier voltage. Then the barrier width will be decreased. As forward voltage increases, what happens? These holes are moving towards like this. These electrons are moving towards like this. Then the potential barrier width will be decreased. At a particular value of depletion, region will become narrow, very much narrow, such that a large amount of majority charge carriers can cross the junction. In p-type, we have holes as majority charge carriers, and in n-type, we have electrons as majority charge carriers. They will cross the junction and constitute the current conductivity in a closed circuit like this. The forward potential at which the forward potential at which the potential barrier is completely eliminated and allow current to flow through the junction is called cut-in voltage or threshold voltage. That is, at which voltage the potential barrier will be eliminated and allows the current to flow through it. That voltage is cut-in voltage or threshold voltage. For germanium, the cut-in voltage is 0.3 volts. For for silicon, it will be 0.7 volts. This is all about forward bias of PN junction.